Inequalities in 1, 2, and 3 dimensions, as shown in the images on the right, for the inequality blank is greater than 4. Inequalities in grades 1 and 2. When I attend conferences in different countries, I look forward to opportunities to visit classrooms, especially young classrooms. In one grades 1 to 2 classroom, the teacher said, "This sentence reads, blank plus blank is less than 8. What two numbers could we add whose sum is less than 8? After a few answers from students, the teacher said, "Record all the pairs of numbers whose sum is less than 8 on your whiteboards. Be sure to record the pairs in a way so that someone looking at them could easily tell whether you found them all." In Ontario, in grades 3 and 4, we extended this activity by plotting the pairs of numbers that fit blank plus blank is greater than 4. The pairs of numbers whose sum is greater than 4 were written as coordinates, like 3, 2. Students used the classroom floor as a coordinate grid to plot blank plus blank is greater than 4 by standing on points whose coordinate sums were greater than 4. What would blank plus blank is greater than 2 look like? We also created 3D coordinates in the classroom using masking tape on the floor and a string from floor to ceiling where the two axes on the floor meet. Students considered what blank is greater than 4 may look like as a plot in 1, 2, and 3 dimensions, as shown on the right. In the grades 5 to 6 mathematics curriculum in Ontario, students solve and represent inequalities in various ways and also learn to use conditional statements in code. In grades 5 to 6 classrooms, students ran this code. They also altered the code and noticed how the plot changed, and they discussed how the code works. In grades 5 and 6, students solved inequalities and coding puzzles. They altered the code to match each of the plots shown below. What changes when we use Scratch to represent inequalities in these ways? With Scratch, we can use conditional structures to represent inequalities dynamically. This creates a cognitive simplicity, allowing students to more easily engage and understand both conditional structures and inequalities. Cognitive simplicities are not automatic. They require careful design of both coding and mathematics concepts to bring mathematics to life in new and more accessible, powerful, and engaging ways.